It's like really light purple. It's clear.
And that, my friends, is acid.
Oh, I think I know why it happened.
Yes, ma'am.
I think it's not. I think that's not. Wait, what would it? Acid. Yeah, that's not.
So you're right. This wasn't an acid before I started blowing into it. But I think that we can test my hypothesis. So we can check and see if it's because of my dragon ancestry, right? By checking to see if anyone else is able to blow the juice clear. Does anyone else want to volunteer to try it out? I'm going to default to our birthday girl here. All right. You saw how long it took me to do it. Just blow, don't suck.
Until it turns clear.
You saw how long it took me, so you just got to give it some time.
Be careful!
There's a reason we put AstroTurf down in here. And there you have it! You turned it clear too! And also got yourself all wet, but still. Here. Would you like some? There. So it seems like Akshita has acid breath too!
No!
You want to know the truth?
Yes!
All of us have acid breath.
What?
All of us have acid breath. So who can tell me what it is that we breathe out? What's the gas we breathe out? Yes, ma'am. Yes, ma'am. Carbon dioxide. Full points. So carbon dioxide is what we breathe out. Do you know what happens when carbon dioxide mixes with water? It forms a very, very weak acid called carbonic acid.
I've heard of that.
So carbonic acid was just acidic enough to be able to turn the base that I had in here, along with a universal indicator that will change color based on whether it's an acid or a base. I had it with just a couple of drops of a very, very weak base. So when we breathed into it and caused enough change in the carbonic acid, that brought it back to being a neutral and burned the pink out of the juice. So yes, every last one of us has acid breath. But we spoke there a little bit earlier about acids and bases, right? Who can tell me a little bit about acids and bases? Does anybody give me an example of both? Yes?
Where's like the trash can?
Oh, sorry, I can take that for you. Anybody with acid and bases? Yes, ma'am.
Citric acid is actually in some fruit.
You are absolutely correct. So things like orange juice and lemonade and various citrus fruits are acidic themselves, as is vinegar, as is a couple of other things. Can anybody give me an example of a base? So a base is sort of the opposite of an acid. If water is completely neutral, an acid is on one side of the spectrum and a base is on the other side. Yes, ma'am?
Is it salt?
I'm sorry? So yeah, depending on the salt, it can be basic. A lot of soaps are bases, for example. We're going to be using one later on in the day called sodium borate, which is borax. Cleaning agents are oftentimes a base. Bases can be just as dangerous as acids can be if you have a strong enough one. So both are things to be careful with. But when you mix them together, they can cause chemical reactions. So, for example, I want to introduce you to a friend of mine. His name's Earl.
What?
Yep. His name's Earl. It's short for Erlenmeyer flask, which is the kind of flask that he is. And Earl has a bit of a problem. Earl is very rude.
What?
Earl is very rude. He has never learned to excuse himself when he burps. Never. I have tried for years and years to get Earl to learn some manners. Excuse you, Earl. I have tried for years and years to get... Excuse you, Earl. Earl.
You put something in there.
I've tried for... Excuse you, Earl.
You put something in there.
So...
Akshita, you put something in there.
I don't think that there's any salvaging Earl's manners at this point. So, but you're absolutely right. I did have some things inside of Earl. I think we named an acid earlier that was a weak acid that we can work with. Who can point that out for me?
Vinegar.
Vinegar. So vinegar is one type of relatively weak acid. I also put inside of Earl a little paper towel full of something else. A very weak base called baking soda.
Baking soda.
Yeah, some of you might have seen this experiment before when I say it. But the reason that they bubble and react like that is because one is an acid and the other is a base. And when the two get together, they have a chemical reaction that puts off a gas. What's that gas we were talking about earlier?
Carbon dioxide.
Carbon dioxide. Carbon dioxide is what's produced when Earl got his chemical reaction.
Me, Akshita, and Brady, and Shreya, when at school we were doing science fun for everyone, and then they did a volcano thing, and they used baking soda. And
Yep, you see the volcano trick oftentimes is a vinegar baking soda reaction. That's one that gets used a lot. So I will say though that they're not every chemical reaction that causes things to bubble and put off gases is an acid-base reaction. For example, I am a big fan of drinking soda. I like soda. I am a scientist of a different generation. It's not good for you, but I still like it. And when I'm at parties, I like to drink soda, but I'm a scientist, and I don't want to do the boring thing and just pour cups. No. I want to have a scientific method of distributing my soft drink.
What in the world? That's so cool.
There's those minties. There's these like
So in order
real soda?
to pour my ginger ale the way that I want to, I just wanted to have it be a little bit more exciting when I pour my soda. So I set up my little scientific soda fountain.
What? No way.
Yep. So who wants to give me a countdown to pour my soda? All right, everybody can give me a countdown. Let's go with 10. 10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
So it didn't work exactly the way I wanted it to, but we're still pouring our soda.
Why is it? Can this happen more than one time?
Not with the same thing of soda. So who thinks they know what it is that I dropped into the soda? Yes, ma'am.
Mentos?
Mentos. That is absolutely correct. So Mentos, when it's dropped into a soda, causes a similar kind of bubbling reaction as when we did the vinegar and baking soda. But do we think that that's because one was an acid and one was a base? No. The reason that Mentos works this way is because of the way that Mentos is made. So Mentos are made by spraying a layer of sugar over something, and then spraying another layer, and then spraying another layer, and 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 building it up until it makes a full thing. Well, every time you spray that layer of sugar, you trap little tiny bubbles of carbon dioxide inside that layer. And you spray another layer, and you trap some more bubbles. And you spray another layer and you trap some more bubbles. And you spray another layer and you trap some more bubbles. And they've got so much compressed gas inside that little tiny Mentos. So when you drop it into the soft drink, it dissolves that first layer, and that compressed gas can get free. And then it dissolves the next layer, and the next layer of compressed gas can get free. And the next layer, and the next layer, and the next layer, until it all bubbles out all over the place, like it did here. So we've been able to see that there are all sorts of different kinds of chemical reactions. Some change things color. Some change things form. They change what the item is by burning it into ash or things like that. Some will change temperature. Chemical reactions can sometimes just change temperature. So I've got a couple of other chemical reactions that I want to do here, but they're a special kind of chemical reaction that I think some of you have heard of before, called burning.
What?
Combustion is a chemical reaction. When you light something on fire, that is a chemical reaction because it causes something to change its form from being whatever it is into ash and smoke. So I'm going to do a chemical reaction here, and I want to count down again. So once I light it, I want people to start counting down from 10. All right? Assuming that my wand will light. There we go. Don't do that.
It's not working.
Yeah, my wand seems. There we go. Just a little bit.
Don't knock it over.
All right.
10, 9,
8, 7, 6, 5, 4, 3, 2, 1. Let's see if it does it. Woo!
I knew that would happen.
So it turns out that we can make little rockets out of paper. Do you think that this was a normal kind of paper that I made it from?
No.
No, we don't think so. What do we think is different about it?
I think it's normal.
Thinner?
It's thinner. Yes,
I
ma'am.
think it's normal.
It's not normal. I will give you that. Yes, ma'am. And more flexible. I'm sorry if I got smoke in your face. That's not what I meant to do. But you're right, it is a little bit thinner. This is actually the kind of paper that you make tea bags with. Tea bags.
Oh, that thing.
And so I actually took 2 tea bags and cut them apart and stuffed them inside each other. So it makes a column of warm air inside the tube that will then lift the ash up once it gets light enough. So let's see if we can do it again. Give me another countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It's like a spider.
That's true. It launched right up into space.
It's like just like a bee.
Yeah, it does look kind of spider-webby, doesn't it?
Yeah.
It's very thin.
Yeah,
So-
it also looks like a bee. It's flying in the sky.
It did kind of while it was floating around. You are absolutely
It was
right.
flying above Earth.
It did. It made it all the way up into space.
Yeah.
So we've also got some other kinds of paper here that when we burn might do something interesting. Do you think, if I were to burn normal paper, what does it turn into? Ash. Turns into ash. So if I burn this kind of paper, what do we think will happen?
It's ash.
You think it'll be ash?
But it
All right.
thinks
Well, we
it's not
can try.
Where is it?
Dude.
Where did it go? What? Did it just disappear? Here, let's try again. Let's see if my eyes were playing tricks on me.
Okay, this is like
My eyes may not be playing tricks on me, but my wand is.
position. You don't know what happened.
Yes, ma'am. What do you think happened?
You let go of the paper, so the paper could not absorb the fire, so the fire went on it, and then the fire disappeared. But I don't know how the fire disappeared.
So I'll actually say that the reason I let go of it was just so I didn't burn my fingers. That was solely so that I didn't hurt myself. But no, this kind of paper, I want to ask, do we think that it just completely disappeared?
No.
No. Does anything ever really completely disappear?
No.
No. I'm glad we got that down. Nothing in the physical world ever completely disappears. It just turns into something else. Yes, ma'am.
If you put more than one layer of that paper, will it disappear?
Only one way to find out.
Let's do it.
Yes, ma'am.
Does it turn to carbon dioxide when the fire is on it?
It doesn't turn to carbon dioxide, but I give you points. It turns into another gas called nitrogen. Now, yeah, you've heard of that. Actually, most of the air that we breathe is nitrogen. Well, there is a lot of oxygen in air. Somewhere around a quarter of the air that we breathe is oxygen. But about 70% of it is nitrogen. And this is a special kind of paper called nitrogenated paper or flash paper. And flash paper, when you burn it, turns completely into nitrogen just as soon as it gets lit on fire.
Ready position?
So let's see about testing our I don't want a bigger fire. That one about got me.
Do another one.
All right, one more.
Ready
Ready
position.
position, thank you. Ready player one.
It's cooler than I'm stuck here. I'm scared. Ready position forever. That's a magic.
So that's a special kind of scientific paper called flash paper. Yes, ma'am.
That is not science. That's a little magic because no one can do that. That does not even
Everyone can do that if you have the right paper. Yes, ma'am.
So can we have the right paper?
It burns the whole thing. It would burn, if I had a big long stretch of it, it would just keep burning and burning and burning until all of it was burned up. Yep. So that's a special kind of paper. So different chemicals. Yes, ma'am.
If you put smoke in it, will the same thing happen?
If I put smoke on it, as in not an actual flame, but just smoke underneath it, no, you would have to actually light it on fire for it to disappear. The smoke itself wouldn't actually cause it to burn. So that is our special kind of paper called flash paper. So before we move on to our next experiment, I do want to go over a couple of quick things I want to make sure that we remember. What are the kinds of materials like plastic and rubber that have long stringy molecules? Does anybody remember their name?
Possum.
Okay, we're okay. Yes, ma'am. Getting close, getting close. Anybody? Polymers. A polymer. So anything that's like rubber or plastic or something stretchy like that is a polymer. And they have those long, stringy spaghetti molecules that get tangled up around things and clump up. What are some signals that we've had a chemical reaction? It changes...
Its shape?
It can change its shape, it can change its form, turns into something else like ash or smoke. It can change...
Oh, I know. It's color.
Color, it can change color. That's a chemical reaction. Or it can change, we didn't really see this one.
Thing, like it's one like that paper to...
Right, turning from one thing into another. And that's what happens when you produce gases, like in the chemical reactions we saw here. So those are some signals of chemical reaction. Let me see, was there anything else I wanted to go over before we started our last experiment? No, I think we're good with those two. As long as you remember those things, we've gotten a successful science day. Yes, ma'am.
What is that for?
We'll get there. That would be our final experiment. But before we get started, before we get started on our final experiment, we're going to do something else in the meantime that will have another chemical reaction for you. So I'm going to start handing these out.
What? Is that milk or what?
So let me just remember back to our first thing. When I hand you something, do you drink it? No, you do not drink it. When we get done making what we're making with it, do you eat it?
No.
Do you feed it to a dog or a cat? No.
We don't have any dogs or cats here.
That makes it easier. So, do you play with it on the carpet? No, because it will get stuck on the carpet. You've got two choices for where you can play with it. Do you play with it outside if your parents tell you it's okay to play with it outside? Yes. Do you play with it inside on a hard surface like a table if your parents tell you it's okay? Yes. So those are your things that we do. I think some of you have guessed what it is we're making here. We're making slime. All right. So let's get these passed around for everybody. Oh, sorry. So non-slime participant there. All right, so someone was asking what it is that I'm actually passing out. This is like glue. It's not exactly glue. It's from the same base that Elmer's glue is, but it's not quite as sticky. They didn't put some of the stuff in it yet. Yep, it's very loose and fluid right now. So yes, don't drink it. Please don't drink it.
Why would we? We're not They stuck to the top. My sister was
You need some, Andy. You need some. Is there anybody who hasn't gotten it yet? Who's making it? You are getting some. All right.
Yeah,
No